Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. My name is Nur Amira binti Asri. So today I would like to explain to all of you about the power amplifier. So the common emitter amplifiers are designed to produce a large output voltage swing from a relatively small input signal voltage of only a few millivolts and are used mainly as a small signal amplifier. Sometimes an amplifier is required to drive large resistive load such as loudspeaker or to drive a motor in a robot, and for this type of application where high switching currents are needed, so power amplifiers are required. The main function is to deliver the power, which the product of the voltage and current to the load. And the second is voltage amplifier difference load resistance connected to the output is relatively low. For example, loudspeaker of 4 ohm or 8 ohm resulting in high current flowing through the collector of the transistor. This power amplifier had been differentiated according to each classes, which are class A, class AB, class B and class C. All these classes had been grouped based on their different characteristic, cue point, efficiency and also distortion level. So today I would like to explain to you guys about the class A amplifier. The main disadvantage of power amplifier and especially the class A amplifier is that their overall conversion efficiency is very low, as large current mean that is considerable amount of power is lost in the form of heat. The efficiency can be calculated by the power output over the power input and times by 100%. The efficiency of class A is between 15% to 25% because the current flows in the output for full 360 degree of the input signal. So, the percentage efficiency in amplifier is defined as the RMS output power dissipated in the load divided by the total DC power taken from the supply sources. The characteristic of class A is biased at midpoint. In the DC load line, it is cut at a middle. This is the DC load line of class A amplifier and it is cut at the middle of the line. The distortion level of class A is output signal is undistorted. It will become the main advantage as it almost no distortion and had good quality. The class A amplifier configuration is the ideal operating mode because there can be no crossover or switch off distortion to the output waveform even during negative half of the cycle. The main applications of this class A amplifier is preamplifier, low power audio amplifier and also the instrument amplifier. So the overall about the class A, the advantage is good quality, undistorted output signal or no distortion, and also the efficiency is low. Thank you.
Hi, my name is Amni. I would like to tell you about the characteristic of class B amplifier. The class B amplifier is used 2 BJT in this amplifier. As we can see, is this a figure about the DC load line, which is this amplifier of class B is biased at the cut-off point. This is a cut-off point, and the Q point of this amplifier at the cut-off point on the line x-axis. So the output signal of this amplifier produce only half cycle. Okay, since class B is produce only half cycle at the output signal, so the full wave can be obtained by using push-pull amplifier. Since the transistor are biased at the cut-off point, so the input signal must overcome VBE before the transistor is on. So the output signal may experience of crossover distortion. The efficiency of the class B amplifier is the current will flow when the transistor is on 180 degree only. This improves the efficiency of class B between 50% to 70%. Let me tell you about this class B amplifier of advantage and the disadvantage. First, the disadvantage of this class B is which current signal at the input signal does not flow until VBE reaches 0.7 volt because of the high distortion level. And the advantage of this class B is where the first is it is more efficient than class A. Second, the standby power consumption is extremely low compared to class A. One device conduct on the other half cycle and the other device conduct on the other half cycle. Lastly, if no signal, neither device is conducting, the quiescent current is zero.
Assalamualaikum warahmatullahi wabarakatuh. My name is Miswani, and for today I will explain about class AB amplifier. Okay. Class AB amplifier is the combination of the advantages of class A amplifier and class B amplifier, and they will combine to produce a better amplifier design. So the purpose of any amplifier is to produce an output which follow the characteristic of the input signal, but it is sufficiently large enough to supply the needs of the load connected to it. Okay. The advantage here is that the DC to AC conversion efficiency is much higher at about 75%, but this class B configuration result is in distortion of the output signal, which can be unacceptable. Okay, so class B amplifier, the amplifier and the class A amplifier and the class B amplifier is combined. Okay, the advantage is combined, and while minimizing the problem of low efficiency and distortion associated with that. Okay, for class, let me tell you about the comparison of class A, class B, and class AB based on the graph. Okay, so let us focus to here. Okay, for the class A, the graph is like this, in which the amplifier's single output transistor conduct for the full 360 degree of the cycle of the input waveform. As you can see, the shading is full from 0 to 360. This is for class A amplifier. So for class B amplifier, the amplifier's two output transistor only conduct for one half, that is 180 of the input waveform. So can you see? The shading is only at the 180 degree to 360 degree. This is for class B amplifier. For class AB amplifier, the amplifier two output transistor conduct somewhere between the 180 and 360 of the input waveform. So we can see from the graph of class AB amplifier, the shading is just between 180 and 360 degree. So, briefly describe, the class AB amplifier configuration is more efficient than class A. Okay, this is AB, so it's more efficient than class A, but slightly less efficient than of class B, because the small quiescent current needed to bias the transistor just above cutoff. Having said that, class AB amplifier are one of the most preferred audio power amplifier designs due to the combination of reasonably good efficiency and high quality output, as they have low crossover, distortion, and high linearity similar to the class A amplifier.
Assalamualaikum and hi, I'm Nuha, and I will explain about power amplifier classes, which I will explain is class C amplifier. The class C amplifier design has the greatest efficiency but the poorest linearity of the classes of amplifier that have been mentioned just now. The previous class A, B, and AB are considered linear amplifier because they are output signal. They are act as the output signals amplitude and phase are linearly related to the input signals amplitude and phase. However, the class C amplifier is heavily biased so that the output current is zero for more than one half of an output sinusoidal signal cycle, with the transistor idling at its cutoff point. In other words, the conduction angle for the transistor is significantly less than 180 degrees and is generally around the 90 degree areas. While this form of transistor biasing gives a much improved efficiency of around 80% to the amplifier, it introduces a very heavy distortion of the output signal. Therefore, Class C amplifiers are not suitable for the audio amplifier. Heavy distortion, audio distortion, Class C amplifiers are commonly used in high frequency sine wave oscillator and certain types of radio frequency amplifier.
Okay.
Class C application that use Class C power amplifier is a radio frequency power amp. A radio frequency power amp is a type of electronic amplifier that converts a low power radio frequency signal into a higher power signal. Radio frequency power amplifier drive the antenna of a transmitter. That's all about Class C. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira. So today I would like to explain to you guys how to know the class of the circuit that is given. So the first one that we need to plug is DC load line. In DC load line, we need to know a few values, which is the value of IC saturations, IC set, ICQ, VCEQ, and also VCE cutoff. To calculate the value of IC set, we will use this equation. This IC set is equal to VCC and divided by the RC and RE. RC and also RE had been given in the question. And 20 divided by 30, we will get the 0.6667 ampere. And this IC set is here in the DC load line. So the value is 0.6667 ampere for the IC set. And next, we need to know the VCE cutoff, which is VCE cutoff is equal to the VCC that also had been given in the question, which is 20 volt. So the VCE cutoff is 20 volt. Okay, the next value that we need to know is the ICQ to plug the DC load line. To find the ICQ, we will using the derivation of this general beta formula, which is beta is equal to IC and IB. But in this case, we got no IB, and we need to find the IB first. To find the IB, we will use the Kirchhoff voltage loop. This is the circuit that given, which is RB, IB, RB plus VBE here. And arrange the formula, we will get the IB equal to the 9.65 milliampere. Okay, the next value that we need to know is the ICQ to plug the DC load line. To find the ICQ, we will using the derivation of this general beta formula, which is beta is equal to IC and IB. But in this case, we got no IB, and we need to find the IB first. To find the IB, we will use the Kirchhoff voltage loop. This is the circuit that given, which is RB, IB, RB plus VBE here. And arrange the formula, we will get the IB equal to the 9.65 milliampere. The next value that we need to know to plot the DC load line is the ICQ. This equation we will get from the derivation of this general beta equation, which is beta is equal to IC over IB. And using this equation, we just need to, from this equation, we need to find the IB because beta had been given in the circuit. So, just arrange this formula and we will get the ICQ, which is 0.386 ampere. Okay, the next value that we need to know is the ICQ to plug the DC load line. To find the ICQ, we will using the derivation of this general beta formula, which is beta is equal to IC and IB. But in this case, we got no IB, and we need to find the IB first. To find the IB, we will use the Kirchhoff voltage law is the circuit at given, which is RB, IB, RB plus VBE here. And arrange the formula, we will get the IB equal to the 9.65 milliampere. So when the value of IB is 9.65 milliampere, we will insert this value into this equation, which is ICQ equal to beta times by IB. Beta have been given in question. So beta, when we times by IB, we will get the ICQ, which is the value is 0.386 ampere. And the next value that we need to know is the VCEQ, which is we will get from this equation VCC equal to ICRC plus VCE. And arrange this formula, we will get the VCE. All the value had been given and we just need to insert, and VCE, we get the value 8.42 volts.
How to obtain the equation VCC equal to IBRB plus VBE?
To obtain this VCC equal to IBRB plus VBE, we need to use the Kirchhoff voltage law and analyze this circuit given. We need to consider from here VCC until here to the ground. So VCC is equal to IB, IRB, and times by the voltage from the BE, from the B to the A, from the base to the emitter in this transistor. So that we get this equation, VCC is equal to IBRB plus VBE. Is there any other question?
I have one question. How to obtain the second KVL VCC equal to ICRC plus VCE?
Oh, a very good question. Okay, to get this equation VCC equal to ICRC plus VCE, we also need to use the same method, which is the Kirchhoff voltage law, and analysis from here. So the VCC is equal to RC, and plus the voltage from the collector to the emitter in the transistor. So that we get this equation VCC equal to ICRC plus VCE. Thank you. Okay, after obtain all the value, we can produce DC load line. And the ICQ value is 0.386 and the VCEQ value is 8.42. And this ICQ will cut this DC load line at the middle. So we make a conclusion that that circuit is class A because it cut at the middle of the DC load line. Thank you.
Hi, Assalamualaikum. My name is Amni. I would like to explain you about to find the type of amplifier from the circuit given. So to find the type of amplifier, what is the type of amplifier? So we must plot the DC load line first, which they have 4 values to find it, such as first to find VCE cut off, VCEQ, ICQ, and IC saturation. Yeah. To find the ICQ, we must which is the formula is beta times 2 IB. What is, we must find the IB first. The IB first is we can know it from this equation, IB equal to VTH minus VBE over this. So to find the IB, we must know what is the value of VTH and RTH. So we must find it from the circuit given. So this circuit, we must short all the supply and will be like this. We must short it to find the RTH and VTH. So the formula of RTH is equal to R1 times R2 divided by R1 plus R2. And will be the answer is 1.803 kilo ohm. And the VTH is this formula is based on the Thevenin's theorem. We must show all the supply. Okay, sorry. Then to find the VTH, the equation is R2 divided by R1 plus R2 times VCC, which is VCC is equation, we know from this equation from this circuit, which is VTH equal to IB plus RTH plus VPE plus IE RE. And we substitute the value and we'll find and we substitute the value from this VTH is 3.60 minus 0.7, which is VPE, and then the answer is 35.107 microampere. This is IB value. So after this, so we can find the value of ICQ, which is beta. The value given is 80 and times IB from this, and the answer is 2.809 milliampere. Okay, so the answer is we plot into the DC dot line, which is 2.809 milliampere. Okay, to find the VCEQ, we obtain from this equation, as known as from this circuit also, and this equation and this again. So the equation is IC plus RC. We flow like this, flow the circuit plus VCE plus IE times RE, and we substitute the value until the equation is 7.0436 volt, and we plot this VCEQ into this, and we plot the Q point, and we got the middle. We know that the formula is VCC equal to VCC divided by RC plus RE. Then the equal is 4.3478 milliampere. Then we plot to DC dot line as saturation. Second, we need to find the VCE cutoff, which is VCC minus IC plus RC times RC. As we know that when we want to find the VCE cutoff, we must assume IC equal to 0. So the IC times RC is 0, then so VCE cutoff equal to VCC only. Then the answer is 20 volt. So we plot the graph into this dot line, and the answer is ICQ and VCEQ. We plot until find in the middle of the dot line, and the conclusion is from this calculation, we know that there are some characteristics of this amplifier that we got, such as it is biased at the midpoint, and the second is the Q point is located at the middle of the DC dot line. So as we know, this is a type of class A amplifier. So that's all from me. Thank you.
Assalamualaikum. Hi, I'm Nuha. Okay, next I will explain to you about the equation power, or we call power dissipated. We have to find the power dissipated in the circuit, because we want to prove that the power in the circuit is not exceed the power rating of transistor given, which is 350 milliwatt. This is the formula that we will use to calculate the power dissipated in the circuit, which is PDQ equal to VCEQ times ICQ. Then we will get 19.785 milliwatt. So that from the answer, this prove that the power dissipated is not exceeded from the power rating of transistor given. We had learned different classes of power amplifier. They had different maximum of efficiency. Okay, so today I would like to explain about how to calculate maximum efficiency for class A. Okay, to calculate it, the first step, you have to calculate maximum power output AC, which is VCC times with VCC divided by RC, and from the result we have to divide with 8. Okay, so we will get this value, which is 13.89 milliwatt. Okay, next for second step, you have to calculate for the maximum power input DC. We have to VCC times with maximum IC. VCC times with VCC over IC, and from this result we have to divide by 2. Okay, then we will get this result, 55.56 milliwatt. Okay, next for the last step, you have to calculate the percent of maximum power maximum efficiency for class A, which is maximum power AC divided with maximum power input DC times with 100, and we will get 25% for class A. Prove that 25% is for maximum efficiency for class A. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. So we have come to the end of this video. Let me give a brief conclusion about what we have taught in this video. So first thing first is we have identified the function of all classes A, B, AB, and C. So regarding to the opinion that we all have we have known that which class is more important, which class is more efficient, and which class is less efficient to be used in a certain circuit. And also for the second task is we already analyzed the classes of the circuit given in the assessment, and we have also know how to determine the class of the circuit given by using a certain method, for example DC load line, and calculate its efficiency. So that's all from us. Thank you.